Hey, hello everyone. My name is Lukas Sismis, and together with my supervisor, I am Korenek, we've been working on analysis of TLS prefiltering for IDS acceleration. Right, today we would like to go to over the introduce the problem and DPDK prefilter, TLS traffic analysis, and then evaluate the proposed solution. Right, so what's the problem with IDS systems? IDS systems analyze a lot of traffic. In today's world, the line rate on the networks can be in hundreds of gigabits per second. However, workers of intrusion detection systems can generally handle 500 to gigabit per second. This basically means you need either to have a set of powerful servers or some acceleration techniques. Common IDS acceleration solutions include improving IDS operation in general, either by using hardware or GPU or something like that, or improving the IDS systems as is, or basically reducing the amount of traffic that IDS analyzes. That's what we are going to focus on. We are basically going to focus on reducing traffic by leaving out encrypted traffic from the analysis, because that's because IDS cannot process encrypted traffic because it's not able to decrypt it. How we approached the experiment, we have a platform called the DPDK Prefilter, which is basically a place where you can put your experiment in. It's an application prior to the IDS systems, in this case Suricata, which can separate your experiment, and you can essentially bypass whatever traffic you want to bypass by your own rules. And in this paper, we've only covered this part and this filtering part. But in other cases, you can also communicate with Suricata or add metadata. How we evaluate how much traffic we can potentially bypass is by analyzing the wild traffic, let's say, the real world traffic. As a testnet is a ISP or infrastructure provider, we have access to 100G networks from which we've captured network data and analyzed it. We've also analyzed the amount of traffic natively bypassed by Suricata. And then based on that, we propose and evaluate the optimization. From the basically analysis which we conducted, there are interesting results. Basically, we can see that 75% of traffic is TLS. That applies both to bytes and packets, and that also applies to academic or commercial networks. That means from 100G network, you can only analyze, let's say, 25 gigabits per second. From the analysis, we've also made the empirical cumulative distribution function of average TLS flow length, which means the percentage of flow, let's say, less than some value. You can see from the left graph that the 90% of flows are less than 100 packets long. And on the right graph, you can see that, let's say, 98% of flows are smaller than 1 megabyte. I'll note that the x-scale, x-axis is in the logarithmic scale. That is because the ranges of the minimum and maximum varied a lot, but this really shows that majority of flow are rather smaller, where I initially assumed or thought that the TLS flows are generally heavy. we've seen, let's say 75% of traffic is TLS, but can we bypass everything? Answer is not really, because TLS contains a plain records as well, which can be inspected by IDS. Those records occur in the TLS handshake when establishing the connection, and upon our further analysis, we have found out that handshake only consists, let's say, of 2.5% of the overall data in terms of bytes. That means we can still bypass, let's say, 96, 97% of data, which is still basically majority of the TLS traffic. However, in our analysis, we found out that Suricata only bypasses 10% of packets and 13% of bytes. That could be basically caused by some incomplete TLS handshakes, missing packets, symmetric traffic, because if Suricata doesn't see the whole TLS handshakes, then it doesn't bypass the flow. However, in our proposed solution, basically, we try to inspect the TLS records in individual packets, and if we see that we receive from both sides encrypted traffic, then we bypass the flow. So we are a lot more relaxed on the bypass rules. In the kind of the core logic of what I explained is in the red oval of the diagram. And in the stateless variant of the TLS prefilter, we don't even care about the opposite direction. We bypass it directly, but that proved to be probably too relaxed, and it doesn't give us the good results. There are some false positives. So, but with the stateful variant, with the both connections confirming the encrypted connection, it provided us no false positives. Basically, from the we've also evaluated the performance of the Suricata, and we've evaluated the performance in per core throughput. So we kind of averaged the overall performance of the Suricata into individual cores. The first line in the table, we see that's the native Suricata with basically the classic bypass, and the third line is the fourth line is the stateful DPDK TLS prefilter, which means that's the TLS prefilter we proposed, and it's a prefilter that confirms from both directions that the connection is encrypted. We see that this variant, the stateful DPDK TLS prefilter, bypasses 60% of packets and 70% of bytes. And compared to AF packet, AF packet XDP TLS bypass, it increases the performance almost 2 times. To have some conclusion about the paper, nowadays traffic consists of around 75% of TLS traffic. That's a lot of traffic, but majority of TLS flows are not that heavy, so we need some very effective bypass on basically a way to not send a lot of traffic to Suricata. And Suricata can do the TLS bypass already, but in some less than ideal conditions, Suricata still processes a lot of traffic. So that can be a case of, let's say, monitoring a backbone networks. And DPDK prefilter, which we are developing, can be a place for your research and experiments, where you can basically separate your experiment from the IDS itself, simulate some software or hardware acceleration technique, and allow it basically allows correct evaluation, where you don't need to make any assumptions when you don't want to hack the IDS systems, but you can just plug the IDS system into your experiment and have basically the real data to confirm your experiment. Soon we are adding the metadata support, which can be helpful to make further decisions in the IDS systems, and that probably expands the possibilities of experiments which can be done in DPDK pre-filter. All right, thank you very much for your attention, and I'm ready to answer your questions. Thank you.